Presenting together is Richard Fairhurst, Senior Project Manager at Laing O'Rourke and Murphy Joint Venture, Philip Robinson, Civil Engineering Lead at Laing O'Rourke, Tim Rowe, Project Manager at Expanded, and Nyasha Ghazi, who is also a planner at Expanded. Over to you guys.
One.
Hello, welcome to our NCE presentation on the future of bridges. We will be explaining how on HS2 we have used Laing O'Rourke's design for manufacturing and assembly approach to change the way bridges are constructed in the UK. Presenting today, we have 4 people. Myself, Richard Fairhurst. I'm the LM Senior Project Manager. We have Nyasha Ghazi, who's the Expanded Planner. Tim Rowe, the Expanded Project Manager, and Philip Robinson, who's the Laing O'Rourke Civil Engineering Leader. LM was formed several years ago as a joint venture on HS2. It's made up of Laing O'Rourke and Murphy, 2 of Europe's most successful and innovative construction and infrastructure organizations. We focus on building information modeling, off-site manufacture, and innovative solutions. On HS2, we are delivering a number of Enabling Works packages. As part of Enabling Works North, phase 1 of HS2. This is a 80-kilometre section of HS2, starting at Long Itchington in the south, up to a tie-in on the West Coast main line. We also complete enabling works for the spur into Curzon Street Station, and you can see a photograph of the enabling works that are currently being carried out at Curzon Street Station in Birmingham. The works that we're focusing on today centre around the new Birmingham Interchange Station site. It is the site of the new station, and we've constructed 4 new bridges to enable highways alterations and improvements in this area. I'm going to show you a video that we put together as part of our planning consent to show the scope of the works in this area. So you can see the triangle that's formed by 3 key strategic roads, and the Birmingham Interchange Station is centred in the heart of this triangle. So it's a particularly busy area outside of the NEC in Birmingham. As we zoom in, you'll see a key point in HS2's critical path, which is the demolition of an existing roundabout over the M42 motorway, and we'll be constructing a T-junction in this area to replace this roundabout. As we move around, you'll see, just coming into screen there, the site of the new M42 bridge, which is the largest of the 4 bridges that we're talking about today. It is a 63-metre span, single span, composite bridge deck on mechanical bearings. As we move further south, there's 2 further bridges. These are known as the North and South Trace bridges. These are 30-metre single span integral bridge structures. And as we pan around, you'll get a feel for the scale of the site and a number of big businesses that operate in the area. There's a number of business parks, Birmingham Airport, a large garden centre, and the NEC. So as we were planning these works, it was particularly important to bring a solution that was going to minimise disruption, that was going to limit the amount of lane and road closures needed to construct these bridges. The 4th and final bridge is the A446 structure. This is a 45-metre single span composite bridge deck on mechanical bearings, and was constructed in a very similar way to the M42 bridge, requiring a weekend road closure to move the bridge deck into position. This is the Birmingham Interchange Station, centred at the heart of the triangle, and you can see the scale of the site that we're operating on. It was a particularly complex area, lots of engagement with Highways England. There's a limited amount of opportunities for road and lane closures. So we needed the certainty of design for manufacture and assembly to make sure that we could hit our programme dates, as we'd agreed a lot of the dates over a year in advance to get the closures needed to construct the 4 bridges. I'll be passing over now to Phil, who's going to take you through our journey through these digital bridges, starting back in 2013.
Thanks, Richard. So my name's Phil Robinson.
I'm the civil engineering leader for Laing O'Rourke in our research and development group. And I've been working on bridge structures with Laing O'Rourke for quite some time now, dating back to 2013 and the A453 widening project in Nottingham. That was for the Highways Agency as Highways England were at the time. And since then, we've worked on a number of other projects with clients such as Network Rail, currently with HS2 that you're going to hear a lot about today, and also future opportunities looking forwards. So that's been our sort of our route to exploring the development of products in terms of our offsite manufacture and DFMA approach. But we've also had a parallel work stream going on with how do we utilise digital tools to actually help us to enable more efficiency throughout the design and construction process and help us to actually configure our bridge structures from standard kits and parts. So I'll take you through that, both those work streams briefly. So starting with our products and our offsite manufacture and assembly approach. One of the key things that we've done throughout all of our projects is to try and take the learning from one project through to the next. So continual improvement of a product set. So we're adding value and creating greater efficiencies as we move forward with every project. And also part of that is really early engagement to actually drive these approaches into the start of our projects. So on the A453 widening, we worked on modularizing and coming up with products for substructure such as piers, crossheads and abutments. And you'll see some of the photographs here show abutments being constructed from precast panels for the front and back face, and then an in-situ concrete poured down the centre. That's how we started off. And then at Stafford, we thought, well, why don't we actually come along and do something slightly more intelligent? Why don't we bring these panels into assembly area and lift them in as a larger lift? And that led to some quite substantial programme savings and labour savings up to 40%, so improving what we've done on A453. And then as you're about to see from Aisha's talk in a short while about the methodology of turning that panelised box into actually, let's just cast the box and have something that's rigidly robust and doesn't require as complex a lifting frame. So you'll see some more details of that soon, but I think you'll see there's quite a considerable savings on offer there with some statistics around that method of delivery. So that's sort of been our product development work stream. And then in parallel to that, we've also been working on our digital work stream. And so we've done some work over the last 7 years, and that's sort of culminated in a recent project with Highways England, which is all about how you utilise digital technology to configure bridges. So if we have a standardised kit of parts and a standardised methodologies by which we construct those components, then why can't we actually configure them in the same way that you might go online and configure your next car or your next wardrobe from a furniture supplier? So that's the principle behind it. It's all about automating a lot of the routine processes that we do every time in our design projects. So we're not actually having to start from scratch every time we start the design of a new bridge. And really what that project is going to deliver is a number of pre-engineered concrete products that allow us to use them on highways bridges. So BBA are the certification body that have reviewed those products in their manufacturing and installation processes to become certified. We've got a design and installation guide that allows the industry to understand how to use those products, along with an approved installer scheme to train up the personnel who will install them. We also have as well as certifying the products, BBA are also looking at the digital tool set to make sure that when we actually use it in anger on real projects, that the actual outputs are valid. And the tool set itself actually outputs an automated production of approval in principle documents, along with the design, drawings and model, and also automatically links through to cost rather than just costing 3 options. We can now cost every single option that we can optioneer through the design of the bridges using the tool. We're also addressing elephants in the room, such as IPR, who owns what, who's responsible for what. That's all important within the contract documents. And I think we can see significant savings throughout the design, construction and assembly of these bridges as we move from move into a world of new digital configuration and offsite manufacturing and assembly for bridges. I'll now pass on to Tim, who's going to talk a lot more about the project itself.
Okay, thank you, Philip. As Phil's already alluded, the digital component set is a vital part of the enabling the bridge construction on site, but it doesn't just end at the components. The digital build and digital design management is the cornerstone of to coordinate the facility and our off-site supply chain, including our supply chain. But what does that actually mean in reality? In general terms, we take the component set and the 2D design information and build the bridges virtually. The logic is that if we don't have enough information to build it in a virtual environment, there's no way we'll be able to build it in reality. This then allows the site team at a very early stage of construction to raise numerous RFIs, TQs ahead of construction, and then limit the delay on the site through information tools. Okay. We also incorporate temporary works and requirements in the model down to the last nut, bolt, shutter, and this enables us to check all of the temporary works and permanent work interface without leaving things to chance. This also allows us to engage directly with our skilled workforce that we have on site, our assembly techniques, and incorporate and communicate any changes that result from those conversations back into the supply chain with minimum fuss. It's vital that standard properties are embedded within the model, so the information we receive from our supply chain for component sets have embedded data, and that embedded data we carry forward into our digital build model, including any on-site items such as in situ concrete and shuttering that all have data. This allows us for the commercial team and the planning function to take those items and actually quantify them for output and development. So going on to video, what we actually get. So ultimately, the digital build and management allows us to build models with time and quantities incorporated into them. We can build these models to reflect planned activity, but as this video shows, it reflects what we actually did, and so we can actually test our outputs and reapply those outputs to future works and future clients to ensure that we get absolute alignment with the client. So I'm going to pass on now to Nyasha.
Thanks, Tim. So early engagement with our manufacturing facility, Expo Manufacturing, through the design process enabled us to be clear on the numbers and the sizes of the components. And as mentioned by Tim before, we're able to link the model to the program, which enabled us to sense check our program sequence, as well as using the digital build, the virtual build, to resolve any clashes prior to starting on site. And we also had visibility of the digital component tracker, which enabled us to view the manufacturing progress and to communicate with the Explore team on priority components that could be called off for delivery as the area of the bridges were being released for the precast install. And on site, we also had constructed a precast laydown area where we could store some of these components ahead of install. So the sequence of the abutment construction will be shown in the video now, which is playing. So this one is of the HS2 South Bridge. Once we had completed the piling and completed the foundations, which you can see the starter bars sticking out there, we then started installing the precast shells. So you can see us installing the precast shells starting on the bottom row. And these shells were either coming from our precast laydown area, or they were just-in-time delivery from the Explore manufacturing facility. And then we just continued working our way up the abutment. And these modular components shells are made out of, you've got single shells and you've got double shells, and you've got some tapered shells. On this bridge, we had all three of these shell components. And you will shortly see some prefabricated rebar cages, which are now brought in from our prefab area. And these are ready, fixed, and they'll be installed within the shell cores. So you can see one just being lifted up, and it's being installed into the shell core. And once we had installed all of these cages into the shells, we then concreted or poured concrete infills into the shell cores, and the abutments were complete. Now, as you can see here with the video finishing, showing you the completed abutment. Now, at the same time we were constructing this abutment, we, on the M42 and the A446 bridges, we were also constructing the deck offline in our SPMT laydown area. Now, on this photo, you can see delivery we were receiving of the bridge steel girders from Cleveland, the Cleveland Bridge facility in Darlington. These started arriving on site in May for the M42 bridge. Sorry, the longer girders were delivered in single girders, and the shorter ones were brace pairs, which you can see on this truck. And once we had assembled this steel bridge, we then installed more precast. Here you can see the deck units which we installed on the deck, and there were also some precast string course units. And then we fixed the deck and we poured, and you can see the largely completed deck here, which was then waterproofed and ready to be installed during our weekend possession, which Tim will go through in the next slide.
Okay. Thank you, Nisha. If you can play the video. And so this is the time-lapse video of the installation of the bridge. So the culmination of all the hard work with the digital building the abutments, and everything Nisha has gone through with the assembly of the deck. What we were left with is a 60-metre clear span or skewed span bridge deck, you can see in the video there. 32 metres wide and weighing 2,750 tonnes. We installed that bridge the weekend, the 7th and 8th of August, on 2 SPMT trains, which you can just see lining up there to go. Each SPMT train had 28 axle lines with 8 wheels per axle, which is by maths 448 wheels to transport the unit out onto the road. As you can see from the video, there's a lot of preparation to be done prior to moving such a big structure on the carriageway, removing the VRS street furniture, and due to the excessive axle loading, 16-ton axle loading of highway standards, protection measures had to be put in place on the top of the tarmac to limit the risk of damage to the subbase the running surface. This culminated in the movement of the bridge, which actually in the end was about 45 minutes from the PMT yard to lining up in position over the bridge deck, over the abutment, sorry. You can see there we had to hold for a period of time for readjustment in the levels, which always planned to make sure that we got absolute precision when we came to the alignment of the mechanical bearings. Once the bridge was in position over the abutments, there was circa 4 hours of fine-tune adjustment with CB UK, Cleveland Bridge UK, expanded engineers, Lang Murphy, technical representatives, and Mahmood to the charge itself. So you can see there lining up on the bearings, which was complete about 9 o'clock in the evening, or complete and SPMTs away by 9 o'clock in the evening, the Saturday evening, which then enabled us to clear away the protection measures on the highway and reinstate the VRS and bring the motorway back into a running condition, opening the carriageway at 7 a.m. on Sunday morning, which was 22 hours of. There you go, whistle stop tour to the installation. Okay, I'll pass it over to Richard to complete the presentation. Thank you.
Thank you, Tim. So yeah, as you can see, a huge amount of effort goes into planning and enabling these types of operations. And one of the reasons we do spend so much time in this area is to make sure that we see the productivity gains on site. You can see in the example here a photograph as part of the time lapse that we saw, assembling a big abutment like that in just 5 days. If we mapped that out onto more of a traditional sense, with all of the formwork, scaffolding, and striking involved in a traditional construction of an abutment, we'd be looking at sort of 7 weeks with 12 operatives, a total of 84 operative weeks. The abutments that we've been constructing here on HS2 have been assembled in just 5 days, with an average of 6 operatives. So a total reduction of 90% in our on-site labour. So a big driver for us is making sure that we can improve the productivity. It's a big challenge for the industry to look at its productivity. We face a skill shortage, getting the right labour onto site, and particularly through a global pandemic as well. It's really played into our ability to deliver, meet our programme commitments, and socially distance on our sites. So for future opportunities, Phil spoke about the digital bridge software. We want to take the lessons from the works that we've completed here on HS2 and refine the system to make sure that we're getting the most benefit out of it, and continue to, through opportunities like we've had today, to talk to clients and consultants around the benefits of off-site manufacturing. We're also very keen to challenge how traditional bridge construction programs are put together. If we can make the most of the opportunity to complete an abutment early, it really opens up the rest of the site that works behind the abutment to complete and change the critical path for how bridges are traditionally put together. So we see these digital bridges as a huge opportunity for the industry to take the benefits of off-site manufacturing, increase the productivity and quality of works on site, minimize the disruption to our stakeholders, and reduce our carbon impact. So we'd like to thank you for your time today, and we will take any questions that you have.
Welcome back. And Richard, Philip and Steve are here now to take a few questions. Thank you all for your interesting presentations. Before we move over to a few questions from the audience, which are now filtering in, Steve, I wondered if you could outline what the changes you're proposing would actually look like.
Yeah, look, it's a good question, Claire. And I think what I'd start by saying is that, I think these changes are entirely possible. In fact, there may be people who have watched my presentation and are kind of saying, well, we're doing that already. And certainly in those organizations where there's a real sense of custodianship over their bridge assets, I think that's possible. But we do know that other contracts operate in different ways. And look, and what we also know is there's great research going on. There have been presentations at events like this before showing techniques using structural health monitoring or whatever else to kind of track how condition is changing. But my point is that we're not doing this as systematically as we could, and that what we need to do is to get that rebalancing between that snapshot in time information and how condition is changing, and what would that look like? To tag defects more clearly, to store data and defect images in a way that it's the first thing that we see if we're looking at a particular defect, to have inspectors with tablets. I know they're using them now, but just with real easy access to the defect history. I think there's a really simple thing we could do, which is to ask inspectors why they're giving a different score to a particular defect. Is that because they think it's got worse, or is that because they disagree with the categorization that was given previously? And we do this, and then we just start to unlock a whole world of possibilities with data analytics.
And do you think that bridge inspectors and engineers recognise clearly enough that the change of condition matters?
Yeah, look, I think they do. I think people really do. I sometimes draw the analogy that it's like if you're crossing a road, what do you worry about most? Where the cars are or how fast they're traveling? And the truth is probably both. But we certainly worry about how fast the cars are traveling. I think bridge inspectors get the same thing. I think everyone understands that we're interested in the state of a structure at a point in time, and we're also interested in how it's changing with time, because that gives us the best tools to predict the future, and we need to know that because that gives us the basis to make strong evidence-backed decisions about the optimum maintenance interventions. So I think this is understood. The thing is, I don't think we've embraced it systematically within the way in which we gather, collect, store, and analyze bridge inspection data. And I think there's good reason for that in terms of the tools that were available to us in the past. But as we migrate towards a future of digital bridge inspections that don't eliminate the human component, but they do, but they're augmented by the digital tools available to us, it's a good time to say, do we need to rebalance this emphasis? Do we need to make sure that the way we move forward has at least as much emphasis on changing condition with time as it does in that snapshot in time information?
So, Philip, do you think the bridge sector is being ambitious enough in adopting digital technology?
So that's a good question. Thanks, Claire. I think that as an industry for the last 5 or so years, we've really been trying to accelerate and keep up with what technologies are around there. But a lot of us as designers and contractors within the supply chain and clients have been experimenting with what's actually what can be achieved and what's useful. And I think there's a certain degree of a need for us to come back together so that we actually don't all run off in different directions, all producing things that don't actually work together. So I think there's certainly a time for us as an industry to now come back and actually try and share as much of this information. We certainly didn't get to where we got to on our project on our digital bridges configuration without speaking to clients that are really interested in how the benefits they could get from this, along with other members of the supply chain, and certainly with the engineering input we've had from WSP and Ramble in terms of what does this mean to an engineer in a phase in an era of automated and parametric configurable designs. What does an engineer's job look like in the future in relation to that, and how does a client get the value out of these tools? So I think there's a lot to think about in terms of how we all work together towards a shared vision and something that everyone wants, particularly when in the public sector we have procurement periods which are sort of 5 years long that contracts are let for. So I think we have to prepare ourselves to go into these 5-year blocks with a joined up and collaborative approach to what we all want to do as part of using this digital technology.
So just remaining on the future, Richard, how do you think the solutions you've outlined benefit the drive towards carbon net zero?
Hi, good afternoon, everyone. HS2 have set some ambitious targets around carbon savings on the project, and it was something we were keen to deliver against, and an off-site approach has helped us achieve that. We're able to look at mixed designs in our embedded concrete from an earlier stage. Producing items in a controlled environment, it enables us to look at those mixed designs around cementitious replacement and content to achieve some big savings versus traditional in situ builds. We also see significant savings in our site operations in terms of the amount of people that are travelling to site, and the amount of deliveries, reducing the amount of deliveries that we need to a construction site. So we capture some significant carbon savings around vehicular movements. And we also produce a lot less waste building in this manner. Against a traditional approach, we would see much higher wastages versus this controlled environment and assembling components on site. So I really see this as a strong strategy for delivering against those targets.
So following on from that, we've got a question coming from Adam Clark asking, is there a span or a skew limit for modular construction?
Shall I pick up on that one, Claire?
Yeah, please.
Yeah. So in terms of is there a span limit and a skew limit for modular construction, I think it's in terms of the normal limits that we have in terms of our integral bridge design limits of the sort of 30-degree skews and the 60-metre span ranges that we might normally look at for integral bridge design, there isn't they still relate to modular solutions. We can still achieve the same principal geometries with modular solutions. I think where you start to define products that can turn corners, say in terms of a geometry of a wing wall that needs to wrap around, to come from the abutment away from the abutment at a certain angle, picking up on sort of certain geometries that you build into molds, they can be created for particular jobs, but if you don't want to have a different angle at the next project, you might want to have a different mold or something that's a sliding mold that can accommodate it. So a lot of this is thinking about it's always the modular piece that sits in the middle of an abutment is quite easy to replicate. When you get to the end of an abutment, how you actually turn the corner is then the question, and it's achievable, and we've done that for integral bridges. So our tool at the moment focuses on the same limits and integral bridge design as you would normally look at as a conventional engineer, but what the analysis that WSP and Ramble have done has really enabled us to look at what do those rules of thumb really mean, because we've been operating on them for years, and actually we're able, with this extra level of detail on top of our analysis, we're actually able to understand, can we push things a little bit further than what the normal rules are. So there's been some really interesting lessons learned about running different geometries and parametric analysis and thousands of iterations to generate the data. It's been a really interesting learning exercise.
Okay, next question is for Steve. Says, you remarked on a critique of assessment management records / condition monitoring. What's your view on the digital built Britain development of digital twin models, improving predictability and optioneering?
Yes, I think this is all in the same direction. I mean, I think whether we look at it from the perspective of digital twins, or I saw there was another question about shouldn't we be holding information centrally and then it gets passed out to inspectors on site. Look, I think this is all heading in the same direction. That idea that we have a digital twin and that we are more strongly connecting the digital model with the physical model and helping to understand it, yeah, that's got to be part of the future. So yeah, I think this is all around those areas where we've got so much potential there to unlock in terms of how inspections are done, how that inspection data then informs decision making. My point is that makes now an ideal time to be revisiting the balancing of this point between snapshot in time versus rate of change of condition, and we should be collecting our information in a way that enables us to understand rate of change of condition.
So do you think we should be seeing more data sharing between authorities to allow bridge engineers to compare their structures with other similar ones around the country, so perhaps they can better predict the deterioration rate?
Yeah, look, I think there are definitely opportunities there as well. I'm doing a piece of research a while back where we looked at the performance of concrete repairs, and we actually found there were some quite major differences, and it just begs some questions around what was different between the way different organisations were managing and implementing concrete repairs. And you think, well, if you could see those, if you could understand the differences or identify the differences, then you could understand the root causes, and then we could share best practices better. So I think absolutely. What I would say though is that bridges are complicated things. They operate in particular locations with particular exposures. The way in which they were built means that they might have different susceptibility to deterioration. So we always need to be a little careful not to think that populations of structures are all part of the same family, when there can be external factors that actually mean that they're behaving quite differently. So I think there's a need to bring a certain degree of caution there. But absolutely, if we've got the better data, then for sure we can be sharing it, and actually unlocking the running some sophisticated analytics around a better data set can tell us all sorts of interesting things.
So we're almost out of time. So if anyone's got any questions for our speakers still to put, you can put them across to swap card. Now we're going to move on to looking at the new Morandi Bridge in Italy, which was built in less than 2 years following the fatal collapse of the original structure in August 2018. I'd like to hand over now to Chiara Butera and Stefano Casula from Italfer, who'll be talking us through the new Morandi Bridge project. And Steve Denton will be joining us again, but this time as a host, to take questions at the end of this session.